Hey, what's up? Last Layer King here. Today I'm going to be going over a blind solving technique called weak swap. So what is weak swap and when would you use it? Well, in a blindfolded solve, you will either get an odd number of edge targets and an odd number of corner targets, or you will get an even number of edge targets and an even number of corner targets. If you have odd edge targets and odd corner targets, that is going to be a case called parity. And the way you solve parity is going to be different from how you would solve the cube if you didn't have parity. If you didn't have parity, the solve would be pretty simple. You would just solve your edges and then solve your corners. If you do have parity, the solve is going to work a bit differently because it will be impossible to solve edges without affecting corners. So what you'll do is, if you take a cube like this, instead of solving edges completely, you will set up two specific edges to be swapped, resulting in a cube that looks like this. So everything here is solved except for UB and UL. They are swapped, and it'll be possible to set this up without affecting any of the corners. Then you'll solve your corners, and you'll eventually get to your last corner target, and you'll have your buffer swapped with another piece, with these two pieces swapped, and you'll finish the cube with a parity alg. If you're using UF and UFR buffers, this will work basically the same way, except instead of having UB and UL swapped, you'll have UF and UR swapped. The key thing to note here is that the way you solve edges is different depending on whether or not you have parity. So at the high level, the way most people deal with parity is they will memorize corners first, and then they'll know from corners whether or not they have parity. And if they have parity, they'll memorize edges such that the UB and UL pieces will end up swapped. So basically, if you have parity and you see the UL edge, you're going to treat it as UB. If you hit the UB edge, you're going to treat it as UL, and that'll essentially swap the two, and you'll get an even number of targets on edges. You will then be able to just solve edges normally because you have an even number of targets, then solve all but one corner and use your parity alg for the last corner. However, there are two scenarios where this does not work. The first scenario would be if you memorize edges first, which is how I solve. And the reason that you can't really use this trick of swapping the two edges if you have parity is because while memorizing edges, you don't know whether or not you have parity. You haven't memorized corners, so you have no clue whether or not you should be swapping these two or solving these two. The other scenario would be in a multi-blind attempt where the memorization strategy is a bit different. So in a regular blindfolded solve, you'll solve the pieces in reverse order that you memorize them. So if you memorize edges first, you will solve corners first, and if you memorize corners first, you solve edges first. With most people solving edges first, that means they'll be memorizing edges first in multi-blind, which means during that multi-blind attempt, you're not going to know during edge memorization whether or not you have parity. Weak swap is the solution to this. With the weak swap, if you have parity, you'll be able to memorize a UB-UL swap efficiently without knowing whether or not you have parity at the start of memorization. Weak swap was originally developed by Graham Siggins and Kevin Matthews in the context of using it in multi-blind, so shout out to them. So with weak swap, you want to get your last target to be UL, and if your last target is UL, that means your buffer is in the UL location. Because in order to have a UB-UL swap, your buffer has to be in the UL location. So the trick here is that whenever you hit your buffer, you want to send that buffer to UL in the correct orientation so that it ends up right here. And if you're doing this with UF and UFR buffers, then when you hit your buffer piece, you're going to shoot it to UR. The terminology Graham used for this case is that the buffer piece in here is pseudo-solved. And I think it's a really good terminology because it may be solved, it may not be. If you have parity, then it's right where you want it to be and you can consider it solved. But if you don't have parity, then it's technically not solved because the buffer would have to end up here. So in the case that you pseudo-solve your buffer to UL, what you're going to find is that because you're treating your buffer as UL, you're now going to be treating the UL piece as your buffer. And you'll get something like this, where you have a piece in your buffer which swaps over to here, which you're now kind of treating as your buffer piece, so it's an odd target. Whenever you get an odd number of targets, what you're going to want to do is you're going to just cycle to that target and then shoot this to UL. And then you'll be able to fix your edges because now they're all solved. The other scenario that you'll find is that you might hit the buffer piece after you hit UL. If this happens, you've basically already treated UL as going to UL, so you're not actually setting up a UB-UL swap. And if this happens and you don't have parity, you can just memo the cube normally. But if you do have parity, you're going to find that you're going to get an odd target. So in this case here, UL is solved, and then the buffer piece goes to here, and this just goes back to the buffer. So in this case, we want to set up a UB-UL swap, so we're going to cycle buffer to here to UL. And now we get the UB-UL swap. So just to give an example here, I'm just going to trace through the pieces and then solve them sort of at the same time. So we have buffer to here to here, buffer to here to here, buffer to here, and now we've hit the buffer piece. So what we're going to do is we're going to shoot this over to UL, because this piece we're going to just treat as the UL piece because we want the buffer to be in the UL location. And if we hit the, I'm doing this specifically because I hit the yellow side of it, and the yellow belongs on top. If I hit the orange side would need to go here for the piece to be correctly oriented. So I'm going to go buffer to here. So now I have this piece set up for the UB-UL swap, and then we have buffer to here, and then buffer to here. And now I've got the UB-UL swap. If you would have memorized this with like any other method where you know you're trying to set up a UB-UL swap, you'll end up getting the same solution. So here's another example. So we'll just go buffer to here, buffer to here, buffer to here, buffer to here, and then buffer, which goes here, and this is our buffer piece. So this time, instead of hitting the yellow side of our buffer, we hit orange. So the orange would need to go right here for the yellow to be in the correct spot. So we're going to cycle buffer to here, and now our buffer piece is in UL. So it's basically pseudo-solved relative to the UB-UL swap. And now with the buffer in UL, we have buffer to here, and this actually goes back to UL. So in this case here, we don't actually have parity, but what we can do here is we can just do the cycle. So we can just cycle buffer to here, and then if we just wanted to swap these two, we'd have a UB-UL swap, but then to finish the cycle, this piece is just going to go to UL. And you'll find that if you did the same thing, but not trying to do weak swap to set up the buffer to UL, you'll get the same number of algorithms. So this wasn't any more inefficient than how you would solve it if you knew you didn't have parity and you were just cycle breaking. Okay, so let's go over another example. So here we've got buffer to here, buffer to here, and now our buffer is flipped in place. So we've hit the buffer, so we have to shoot it to UL, but we have to actually shoot this to LU because the orange side needs to go on the LU sticker so that the yellow can go on top. So this is going to go to here, and this goes to here. Okay, so now we have this piece going to here, and this goes back to UL. But we already put the buffer piece in UL, and we want to keep the buffer piece in UL because if we have parity, that's actually where the buffer belongs. So what we're going to do here is instead of cycling here to here, in this case we'll get this two-edge swap, which is going to take two algorithms to set up a UB-UL swap from. We want to just keep the buffer here, so we're just going to cycle break after this piece. So we're going to shoot here to here, and I'll just cycle break to here because it's a convenient algorithm. So this piece is going to go to here, and now our UL piece is in the buffer at the end of it. And we've set up the UB-UL swap in one less algorithm. So whenever you have shot your buffer to UL, if you ever hit the UL piece, just cycle break. Don't shoot it to UL. As long as you cycle break, you'll always get the UB-UL swap. Now, if this happens on a solve where you don't have parity and you cycle break on the UL piece, you're going to find yourself with an odd number of targets. And whenever that happens, whenever you get an odd number of targets, you're just going to do a comm that cycles your buffer to wherever that odd target is, and that'll go to UL. So here's just an example. So say you shot your buffer to UL, and you shot the UL piece like somewhere like over here. You'll end up finishing your last cycle on here, and this would be like the last target you memo. So what you'll do is if you have this buffer piece in UL and you just cycle here to here, you'll just find that all the edges are solved, and the solve will be as efficient as it was if you just memoed it normally. Now that I've kind of showed how the pieces move around as you do weak swap and how the buffer piece ends up in UL, let's do some example memos, but without actually manipulating the pieces while showing what we're memoing. So this will be just like a regular memo and a regular solve. So I'll put the scramble in the video. You're going to want to scramble in your orientation, and if you use UF and UFR as your buffers, go in your orientation and then do a Y2, and then do the same scramble, and you'll find that you'll get the same type of cycle breaks, and then instead of like weak swapping UB and UL, you'll be weak swapping UF and UR. Okay, so here we have buffer to here, which goes to here, and now I've hit the buffer piece. So we hit the orange side, which means we need to move this to the side, which is going to be over here. So we're going to weak swap this piece to here, which goes to here. And then we have here, and this is the UL piece. But because we memoed the buffer piece going to UL, this piece is going to go somewhere else. So we're just going to cycle break somewhere. So we're going to have buffer to here for the next cycle. And then we have here to here. And then this goes back here, and that's our last target because we just finished the cycle that we cycle broke on UF. So that means our last cycle is going to be buffer to here, the odd target to UL. So now executing it, we have here to here, here to here, here to here, and now we have our buffer piece pseudo solve to UL, here to here, cycle breaking to here. So now we have basically this would be our buffer, except we are cycle breaking with the UL piece instead of the buffer. So we now have this piece going to here. And then the last target, we have this odd target here, which goes to UL. So that's exactly how I memoed it, and now we've got all the edges solved. So let's do another example. So once again, in your orientation, but if you use UF, UFR, go to your orientation and then do Y2. So we have buffer to here, which goes to here, and now we hit the buffer. So because we hit the top side of our buffer, the yellow side, we're going to shoot this to the top. So it's going to go to here, and now we hit UL. So we hit UL, so we have to cycle break somewhere else because we already shot our buffer to UL. So I'll just cycle break to here, which will go to here. And then we have here to here, and that finishes the cycle, so I'm done. So now solving it, buffer to here, buffer to here, and then here to here. This pseudo solves the buffer to UL, here to here, and then we had cycle broke to here, and then we have here to here. And now we've got the UB-UL swap in ready to solve corners. So let's do another example. So we have buffer to here, which goes to here, which goes to here, and this goes back to the buffer. Now we've already memoed to UL, so we can't really weak swap this, so we're just going to cycle break. So I'm just going to cycle break up to here. This goes to here, which goes to here, and then this goes back here, and now we finish the cycle. But this is an odd target. So what we're going to have to do at the end of edges is go buffer to here, and then shoot this to UL. So now solving it, we have buffer to here, buffer to here, and then we cycle broke to here. Buffer to here, buffer to here, and now we basically have this swap here. We need to make a UB-UL swap, so we go buffer to here, and now we've got the UB-UL swap and we're ready to solve corners. Okay, so now let's go over some special cases. So this scramble, we're going to find that there is a flipped edge, so let's just get into memoing. So we have buffer to here, which goes to here, then we have here to here, and then we have here, and now we've hit our buffer. So we hit the side color of our buffer, not the top, so we're going to shoot this to LU instead of UL, so it'll go to here. This goes to here, and this is the UL piece, except we should hit the yellow side of it, because the yellow side is going to end up in the buffer location. But because we hit blue, that means there's a flip somewhere, and the flip is back here. So what we're going to do here is we're going to cycle break into the flipped edge. So we can either go to this target or we can go to this target. I like buffer to here to here. And then this is going to go to here to finish this cycle. And this is an odd target. So our last cycle is going to be to here to UL. So now solving it, here to here to here, here to here to here, here to here to here, here to here, and then we're shooting this to LU for weak swap. Here to here, and then we're cycle breaking into this flip. And then we have to finish this cycle, and then we have to shoot it back to UL because we have an odd target. And we find that all of our edges are solved and we're ready to do corners. So here we got another one. So we have buffer to here, which goes to here, and now we've hit the buffer piece, so we're going to shoot this to LU because we hit the side and not the yellow. So it'll go to here, which goes to here, which goes to here, which goes to here, and once again we hit the blue side of the yellow-blue piece. So we hit LU instead of UL, so there's a flip somewhere, and it's right here. But because we hit this on an even numbered target, we can't really cycle break into this flip. So this is actually going to be a case where we have parity. In the other solve, we didn't. So we're going to just memorize that this piece is flipped. I would usually just memorize that visually. And then the solve would go like this. So buffer to here, buffer to here. That's going to pseudo solve the buffer to UL, here to here. Then we go here to here, and then here to here. And then it's very important that you solve this flipped edge before you solve corners. Normally I would already have like all but one corner solved, so if you solve all but one corner and then set up your edges and solve your last corner, you really have to do this flip alg before you solve your last corner. Otherwise, this piece will end up moving over and you'll flip the wrong one. So we're going to do the flip alg now. And now I've got our UB-UL swap and we're ready to solve corners. So here is another one. So in this case, we have our buffer flipped in place in the scramble. So normally when this happens, you would just cycle break, but we can just handle it the same way as we would with weak swap and then just immediately shoot this to LU. If the buffer was solved in place, we can just make our first target UL, and we basically just pseudo solve the buffer to the UL location. So the solve will just go like this. So we'll buffer to here to here, 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 and we hit the blue side instead of the yellow side, so we have a flip somewhere and it's right here. So now solving it, I'm just going to solve corners really quick. So like in a solve, I would be at this point and I would have parity. And then I would just go through my edge memo, buffer to here to here, to here to here, to here to here, to here to here, to here to here. And now we have this flip. So we're going to do the flip alg to flip the buffer and this piece. And now we've got our UB-UL swap, so we can just finish the cube with a parity alg. So here's our last example. So we have buffer to here, which goes to here to here. Now I've hit the UL piece, but we find that our buffer is in UL. So we're actually not going to shoot the buffer over to here. We're just going to cycle break because this piece is already pseudo solved for the UB-UL swap. So we're just going to cycle break, and I'll just go to here, which goes to here, and then to here, and then to here, and this finishes the cycle, and then we have a flip. So we end up with getting 5 letter pairs plus a flip. And the way we solve it is we're going to go here to here to here. And then we have here to here to here. And then we're just cycle breaking right here, which goes to here. And then we have here to here to here. And then we have here to here to here. And then after I do the flip, we have the UB-UL swap. So that was 5 comms and a flip alg. You'll find that if you shot the UL piece to UL, you'll get an odd number of targets, and then you'll have to shoot the buffer back to UL. And then you'd end up doing 6 comms plus a flip. That's all the examples I have. I hope you found this tutorial instructive. This is going to be the first video in a series of videos on a technique that I've developed that I'm calling Advanced Weak Swap. This series is going to be targeted toward those of you who are proficient with 3-style and are ready to learn some more tricks to step up your game. Advanced Weak Swap is basically a framework built on top of Weak Swap, combined with a few algorithm sets that you can use to make your solves more efficient and more cool. I'm going to be going over Advanced Weak Swap from the context of using UB and UBL buffers and setting up a UB-UL swap for parity. However, the concepts work basically the same with UF and UFR buffers, and you can do Advanced Weak Swap just as effectively as you would with UB and UBL buffers. I'm also going to be going over Advanced Weak Swap from the context of memoing edges first and solving corners first. I know most people memo corners first and solve edges first, but that's not really going to affect how Advanced Weak Swap works. You'll just know at the start of edge memo whether or not you have parity. But I'm going to be going over the concepts from the context of not knowing whether or not you have parity while you're memoing edges. I'm looking forward to making this series. I'm probably going to upload about 1 video per week on it, so I'm pretty hype. I hope you are, and I will catch you in the next video.